Hi everyone, welcome to talk session. In this session we will learn how to design DFA which accept all strings of length exactly 3 over sigma a comma b. Let's start writing minimum length string based on the given condition. What's the condition? Here length of the string should be exactly 3, not less than 3 and not more than 3. It means what? Any symbols 3 times. Here sigma is a comma b, so it may be triple a. Any 3 symbols, it may be triple b or it may be combination of a and b, like here bab. If any string coming less than the length 3, it won't allowed. If it is a more than 3, it will also not allowed. So once I understand this condition, let's start designing the automata. Our automata starts with the state q0. As there is no epsilon in the minimum length string, our q0 will not be final state. Then triple A should get accepted, or I can say triple B should get accepted. Here my focus is not on the symbol. Here my focus will be on the length of the string. Either it may be A or it may be B. So if first symbol is A, whether A should get accepted? No. So it will go to the non-final state Q1. Second symbol is also A. Second symbol should get accepted? No. So transition of the second symbol will go to the non-final state. Third symbol is A. Third symbol should get accepted? Yes, because after reading the third symbol, length of the string becomes 3. So as length of the string becomes 3, it should go to the final state. So for third symbol, transition should go to the final state. Hence I am making this Q3 as a final state. Similarly, if I want to read triple B, then first B will be read by the Q0. I am utilizing the existing transition. How to read this? Q0 can read A or Q0 can read B. First B has been read by the Q0. Then second state is Q1. Next symbol is also B. So Q1 can be reading A or B. Next symbol is B. Then Q2 can be reading B. It means what? By reading the string of length 3, it should go to final state. So after reading triple B, first B, second B, third B, automata is going into the state Q3 and it's a final state. So triple B is accepted. And if you observe this, Q0 is deterministic. Deterministic means what? There must be one transition for A as well as for B, as sigma is A comma B. Hence there is a transition for A as well as B from the Q0. Similarly, there is a transition for A and B from Q1 and same with Q2 also. But there is no transition from Q3 for any A or B. Now we want to make string as a deterministic, then I want to make Q3 as a deterministic. Then I told you step by step process how to make Q3 deterministic. I want to find transition for A. At which state? Q3. Then ask yourself how to reach to Q3 from the starting state. Q0 is my starting state. To reach to Q3, I need to follow this path. Q0 to Q1, Q1 to Q2 and Q2 to Q3. While following this path, I need to read some symbols. For example, Q0 to Q1, I need to read A or B. If I am reading B, Q1 to Q2, I need to read A or B. If I am reading A, Q2 to Q3, I need to read A or B. If suppose I am taking B, and at Q3, I am looking transition for A. Ask yourself, is this a valid string? What's the length of this string is? 4. What our condition says? Our condition says that length of the string should be exactly 3. This is more than 3. So this is not allowed. Hence, this is an invalid string. And as we know, for invalid string, automata should go to the dead state. Hence, transition for A from the Q3, transition for A from the state Q3 should go to the dead state. Hence, I am writing here transition from Q3 for symbol A to the dead state. Similarly, if I want to find out transition for B from the state Q3, how I can find out? Same way, write down the symbol. For which state you are looking transition? Q3. How to reach to Q3 from the starting state? Q0 to Q3, how to reach? By reading any 3 symbols. If I write the same example, by reading any 3 symbols, I am reaching to Q3. At Q3, I am looking transition for B. Now ask yourself, is this a valid string? What's the length of the string? 4. What our condition says? We want string whose length is exactly 3. This is not following our condition. Hence, this is the invalid string. As we know, If automata is reading the invalid string, automata should go to the dead state. Hence, transition from the state Q3 for the symbol B. For the symbol B, this transition should go to the dead state. I am utilizing the existing transition. How to read this? Q3 is reading A or B going to dead state. This is also one of the state. So this should be deterministic. There should be transition for A and B from the dead state. As we know, once automata is in dead state, means what? Automata has read something invalid string. Already it's in a dead state. If again any more strings are coming, maybe A or B, 0 or many times, so give the self proof, automata will be in the same dead state. Hence, this is the final answer to this question, to accept all the strings of length exactly 3. You can practice similar kind of question to accept all strings of length exactly 2. In the next few sessions, we will see how to design automata where length of the strings are divisible by 2 or divisible by 3 or 5. Thank you for watching.